Hi fourth graders, and welcome to day 1 of exploring fractions as tenths and hundreds. So the last couple of weeks I've been just focusing on fractions in general and using models to help us. Now our focus is going to be thinking of them as having a denominator of 10 and 100, okay? So today we're going to be working on pages 519, 520, and 521 together, and then you'll be doing page 522 on your own, okay? So let's get started with page 519. So Doss rides his bike home. He has 7/10 of a mile left to ride. Write an equivalent fraction to show how far does Doss have to write an equivalent fraction to show how far Doss has to ride in hundredths of a mile. Okay, so we're gonna start with 7/10, and we need to figure out a way to make an equivalent fraction with 100 as the denominator, okay? So we have two different strategies, so we're going to call this one strategy 1, and then we're going to divide our paper, and then we're going to call this strategy 2, okay? So strategy 1, we're just making an equivalent fraction, so we have 7/10, and then to get to 100, 10 times what gets me 100? Well, 10 times 10 equals 100. Whatever we do to the bottom, we have to do to the top. 7 times 10 is 70. So that means an equivalent fraction is 70 over 100. So 7/10 is equal to 70 over 100. Okay? Easy, right? It's just like having our regular equivalent fractions, just this time it tells us we need to have it in hundredths of a mile, meaning this has to be our denominator, okay? And then sample B would be using the base 10 block. So first we're going to have 1 divided up into 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I did a little too much. Sorry, friends. Pretend this one is not here. I apologize for that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we shade in 7. 1, 2, 3, 4, 5, 6, 7. So this is showing our 7/10. It's poorly done by me, but don't make the same mistake I did. And then we have an equivalent. So that means when we have our 100, I'm just going to roughly do this, friends, so it might be a little off, but that's fine. It should be a 10 by 10, but clearly I'm not doing too well with the drawing today, so we'll just say this is a 10 by 10, and it's going to be shaded up the same way. So 1, 2, 3, 4, 5, 6, 7. So that means all of this is shaded in. So that's 70 over 100, okay? But as you can see, this is where it gets tricky, and finding equivalent fractions this way is the more foolproof way, right? So, and it's because for part 2, there are 10 hundredths in 1/10. 7/10 is the same as 70 hundredths. So then Doss has 70 hundredth miles to ride. Sounds way worse than this way for sure, right? But it's still the same as 7/10. Okay, so like I said, obviously our original way of finding equivalent fractions is much more foolproof, especially when we're doing the drawing. As we can see here, Miss Deanna is not an artist. So definitely make sure we're refreshing how to make equivalent fractions this way, okay? If you have a question, pause here, please. If not, we're going to move right on along to page 520, and then we'll have our definition page, and then you'll be on your own, okay? So, looking back, explain how you could use multiplication to find a fraction with a denominator of 100 that is equivalent to 7/10. So what we're going to do is basically put into words what we did with strategy 1 here, okay? Because they're asking how we can multiply. So you can multiply the numerator and denominator in 7/10 by 10, right? So multiplying everything by 10 to get the equivalent fraction $7/100. So again, it's putting what we did on the first page into word form, okay? Now, number 2, every fraction with a denominator of 10 can be written as a fraction with a denominator of 100, right? So the model at the right is divided into 10 equal parts, or tenths. How many parts are shaded? So we have 1, 2, 3, 4, 5, 6, 7 parts shaded. And then if you split each tenth into 10 equal parts, the whole is now divided into 100 equal parts, or hundredths. So A is in tenths, B is in 100. So how many hundredth parts are shaded? Well, that's just saying 7 times 10, so it is our 70, okay? So this is 10, 20, 30, 40, 50, 60, 70. So this is 7, this is 70, okay? And that's just showing what we broke apart to find the equivalent fraction, and it's just way better than my drawing, right? We can clearly see it lines up here, meaning they are in fact equivalent, okay? So complete the equation to show a fraction with the denominator 100 that is equivalent to 7/10. So it's just filling in the blanks of how we solved it on the previous page. So 7 is equal to 7 times blank equals blank, and then 10 is equal to 10 times blank, which equals 100. So we already know 10 times 10 gives us 100. Whatever we do to the bottom, we do to the top. So 7 times 10 is 70. Okay, so it's just having us fill out the blanks for what we just solved on page 519. So you can also use money to think about equivalent fractions with denominators of 10 and 100. Think of $1 or 100 cents as a whole and fill in the blank. So we know 1 dime is equal to 10 cents, right? So that means it's 10 out of 100 of a dollar, because 100 is equal to a dollar. So 1 dime is equal to 1/10 of a dollar, because a dime is worth 10 cents. So 1/10 is equal to 10 100ths. And we can also prove that by saying, well, 10 times 10 is 100, 1 times 10 is 10, right? So it's just letting you also think of it in a different way if money makes more sense to you, or if it's just easier to keep it as your rule for equivalent fractions, that is fine too. So we are going to skip 3 because I want to make sure we have some time to fill out our vocabulary. So if you do not have any questions on page 520, we're going to flip. If not, please pause here to ask, okay? So let's fill out our vocabulary table. First word we have is a numerator. And a numerator is the number above the line in a fraction. It tells the number of equal parts that are described. And an example of that, if we have the fraction 3/8, the 3 is my numerator. Now my denominator is the number below the line, so it's the number on the bottom, the number below the line. In a fraction, it tells the number of equal parts of a whole. So if in 3/8 the 3 was the numerator, the 8 is the denominator. So that means 3 out of the 8 total pieces are shaded. 8 is the number of equal parts, okay? Now we have the words tenths and 100ths. So tenths are the parts formed when a whole is divided into 10 equal parts. So 3/10 is 3/10, right? Kind of silly to write, but it's just saying that our model is divided into 10 equal parts, 3 are shaded. So it's going to be the same idea for hundredths, just instead of 10 equal parts, it's going to be 100 equal parts. So the parts formed when a whole is divided into 100 equal parts. So example, 3/100ths is 3/100ths, right? So 3 out of, well, 300, sorry, not 100, 300ths. And it ends in THS, so it's not hundreds, it's hundredths, okay? So if you need to pause here to write, that is totally okay. Just make sure you show me your completed table, okay? So just make sure you show me that for today's credit for class. And if you don't have any questions, you can jump right into page 522, okay? Happy tenths and hundredths.